Hello everyone, and welcome to the implementation of a shell sort lecture. So, just as a review, the shell sort improves on the insertion sort by breaking that original list into a number of smaller sublists. And then each of those sublists is using an insertion sort. So the unique way that these sublists are chosen is the key to the shell sort. Instead of breaking up that list into sublists of continuous items, what the shell sort is going to do is use an increment I, which is sometimes called the gap, to create a sublist by choosing all items that are I items apart. Okay, so we've seen those figures that show that idea in the previous lecture. You can go ahead and review them, or you can go ahead and check out the resources for review here in the Jupyter Notebook. But what we're going to do is go ahead and implement our shell sort. And we're actually going to use two functions here. We're going to have our main shell sort function, and then we're going to create another function to do the gap insertion. So that will be this function here. So let's go ahead and get started with our basic shell sort. So I jumped over to a new tab here in the Jupyter Notebook, and I'm going to say, let's say shell underscore sort, and pass in some array. Okay. First thing I'm going to do is go ahead and say sublist count is equal to length of array divided by 2. And then what we're going to do is then say, well, we still have sublists, so while sublist count is greater than 0, for, and I'll say for start in range all the way up to the sublist count, this is where I'm going to do that gap insertion. So I'm going to say gap underscore insertion underscore sort, and that's going to take 3 arguments. And this is the new function we're going to develop in just a bit. It's going to take in that array, it's going to take in a start, and then it's going to take in that sublist count. And then once we've done that, after we do that for loop, what we're going to just go ahead and do is say sublist count is equal to sublist count divided by 2. Okay, so now let's go ahead and focus on this gap insertion sort. So we're going to say def gap underscore insertion underscore sort, and again it's going to take in an array that starts, but instead of saying sublist count, what we're going to just go ahead and treat this as is that gap that we discussed earlier. So I'm going to say for I in range, and in this case we're going to have our starting be our start point plus that gap all the way to the length of the array, and we're going to go in steps of the gap. Okay, and then let's go ahead and make a variable called current value and set it equal to whatever that value is at this index of the array. And then let's go ahead and say position equals I. So we're basically doing the same thing as we've done in a few other algorithms, set a current value and a current position. And then using that gap, what we're going to do is say while position is greater than or equal to gap, and the array value at the position minus the gap is greater than that current value. Here's where we're going to do essentially that exchanging. We're going to say position, or that shifting, position minus gap, and then say position then equals position minus gap. So we're switching both those values and those index positions themselves. So we're using the gap there, and then at the end what we have to do is after this while loop, just go ahead and set that current value. So just say the array at that position is just equal to the current value. Alright, so we've made our 2 functions. Before we go ahead and break them down more, let's just make sure that they work out. So I'm going to go ahead and copy from the other notebook this test array and this test call, run them, and it looks like in fact we're good. It actually did sort. So let's go ahead and zoom out and then see if we can break down what's going on here. So first thing we want to notice is how we're actually choosing the increments or those gaps, those sublists here. So in this particular method or implementation, what we're doing here is we're beginning with n over 2 sublists. So if this array has n elements, then our first sublist is going to be n divided by 2. And then on the next pass, what we end up having is n divided by 4, right? Because we're dividing that thing again by 2. So 1/2 times 1/2 is 1 over 4. And then we're taking that length of the array, which is going to be n items of the array, and then dividing it by 4. So on the first pass, you start with n over 2 sublists, next pass, n over 4, and then eventually a single list is sorted with just that basic insertion sort. So what you can do, if you want to visualize this a little more, is actually create a print statement. So you can go ahead and put a print statement after this for loop, and you can go ahead and say print, in this case, let's say after increments of size, and then let's go ahead and just say sublist count here, and then we'll print another a line here. The list is, and then what we're going to do is just put that array value there. So let's make sure that worked out. Okay, so here we have our increments, so let's just go ahead and check the length of that array so we can get an idea of what's going on here. So we have 11, so closest 11 divided by 2 rounds off to 5. So after the increments of size 5, we essentially have this list. Increments of size 2, we have this list. Increments of size 1, we end up getting this list. So you can go ahead and review the previous lecture on the actual shell sort, and how we had those sublists and the insertions, and then those final insertion sorts when we had the increments of 1. Go ahead and check them out. Those figures are really helpful. But essentially remember that with the shell sort, we're just improving on that insertion sort by breaking the original list into a number of smaller sublists, each of which are then sorted using an insertion sort. And the key to this is that unique way that these sublists are chosen in the shell sort. So instead of breaking that list into a bunch of sublists of continuous items, the shell sort uses that increment I, sometimes called that gap, and that creates a sublist by choosing all the items that are I items apart. Okay, so go ahead, write this out yourself, make sure you understand it. I really suggest using print functions to help you keep track of what's going on throughout the functions and your function calls. That's super helpful. So if you're ever not understanding 1 or 2 lines of code, try putting a print statement there and seeing what's actually happening. Go ahead and print out different variables so you can get an idea of what's actually being sorted, where are your sublists, where are your gaps, etc. Okay, with that being said, that's the implementation of the shell sort, and I will see you at the next lecture. Thanks, everyone.